In this video, we're going to take a look at some examples from lesson 7.1, which has to do with simplifying or verifying trigonometric expressions. This particular skill is used extensively in calculus to help you simplify a trigonometric expression so that it is easier to perform the integration or take its derivative, which are common things that you would do in calculus. Before we get into the examples, I want to point out to you it would be important, even as you're working through these problems, to have the formulas handy. After lots and lots of practice or years of practice, you might remember them, but initially you may need some help. So in the course content, if you log into the course and go to content at the top of the page, and then scroll down and select final exam. Okay, so I'm going to scroll down. I'm going to click on final exam, and under the final exam folder is a Math 1113 final exam formula sheet. And so on this formula sheet, it has all the formulas that you'll be able to use on the final exam, but specifically for what we need, it has our reciprocal identities, our tangent and cotangent identities, Pythagorean identities, cofunction identities. And so they're all kind of there summarized on one page. So if you haven't already printed off this formula sheet, I would strongly encourage you to do so prior to the final exam. Okay, so I'm going to toggle over to the problems, and these are worded like the problems that you would see in lesson 7.1 in WebAssign. And so the first question says, which expression, and it's a multiple choice question, but I'm going to work it out without having the choices there. Which expression is equivalent to tangent squared x plus 1, all divided by secant squared x for all values for which x is defined? Okay, so I'm looking at that. They want me to simplify it. I noticed that the top or the numerator of this fraction involves tangent and the denominator involves secant. And I seem to recall that there's a formula, a Pythagorean identity that has to do with the secant and tangent. And so the Pythagorean identity, 1 plus tangent squared equals secant squared. Okay, so I'm going to use that Pythagorean identity to help me simplify this particular problem. Okay, so I'm going to use the Pythagorean identity. And it'll help you if you kind of keep in your mind, typically with Pythagorean identities, there's going to be a connection between sine and cosine. That's the first one. The second one, there is a connection between secant and secant and tangent. And then finally, the third one, there's a relationship between cotangent and cosecant. So if you kind of keep that in mind when you're working through these problems, that will help you out. The identity that we're going to use is 1 plus tangent squared x equals secant squared x. Now, although it's in a different order, but addition, remember, is commutative, I can basically do a direct substitution. In place of tangent squared x plus 1, I can put secant squared because they're equal. They're the same all the time, every time. So if I rewrite this, I'm going to rewrite it down here. Tangent squared x plus 1 over secant squared x becomes I'm not going to mess with the secant squared x in the denominator, but I'm going to replace tangent squared x plus 1 with, oops, sorry, it jumped on me, with secant squared x. Okay, so I'm replacing, I'm basically doing a substitution. Secant squared x. So all I really did was use the identity that I know, and I've done a substitution, much like you would do in algebra, and you just are substituting an expression for another expression rather than doing, like subbing a number in. And then I realized that I could simplify this because I have secant squared in the numerator and a secant squared in the denominator. And when they divide out, there are placeholders there. The understood placeholder is 1, so you have 1 divided by 1. So ultimately, the expression tangent squared x plus 1 all divided by secant squared x is actually equal to a value of 1. And I'll tell you, using a value of 1 as opposed to that gloobly glop expression with trig functions in it is going to be a whole lot simpler in calculus than, so you want to make sure you do that. Okay, so the next one, which expression is equivalent to sine squared times cosecant squared x minus cotangent squared x? Again, this was a multiple choice question, but I'm going to actually work it out for you. Here, what kind of jumps out at me is that I have cosecant squared and cotangent squared. And I just mentioned that there's a Pythagorean identity that has a connection between those two functions. So I'm going to see what that does. Now, sometimes, guys, with these type problems, these are where in trigonometry you can get creative because there's usually more than one way to work the problem. Ideally, we try to do it the shortest way or the simplest way. But if you see something different, go for it. It may or may not work. Okay? So I'm going back to my formula sheet for a minute to look at the formula. So my Pythagorean identity that involves cotangent and cosecant is 1 plus cotangent is equal to cosecant squared. Okay, so my Pythagorean identity that I want to use here is 1 plus cotangent squared x equals cosecant squared x. And again, what we're going to do is use the idea of substitution to help us work this problem out. So I have sine squared x times cosecant squared x minus cotangent squared x. And so again, using that Pythagorean identity, I'm going to do a substitution in place of cosecant. So I have sine squared x times, and in place of cosecant, I'm going to put the identity 1 plus cotangent squared x. All I did again is a direct substitution. I replaced one expression for another. All the other pieces remain the same. And then I'm going to do some basic algebra, basic math, and I'm going to combine like terms. So I have sine squared x cotangent squared x minus cotangent squared x is going to zero out, and I'm left with 1, or 1 plus 0, which is 1. And then we have 1 times sine squared, which is simply going to be sine squared. Okay, next example. We have sine squared plus cosine squared, all divided by sine squared x. Now here again, there are a variety of ways that you can begin. Again, the thing that jumps out at me initially is this sine squared plus cosine squared that's in the numerator. And again, I remember that for a Pythagorean identity, that sine and cosine are connected. So my Pythagorean, I'm going to use the Pythagorean identity again. And it is, I believe, sine squared x plus cosine squared x equals 1. We can go over and check that on our formula. Yep, sine squared plus cosine squared equals 1. Okay, so I'm using that Pythagorean identity. Okay, I'm going to write the problem down, bring the problem down again. So I have sine squared x plus cosine squared x all over sine squared x. And again, I'm going to do a direct substitution. My sine squared x in the denominator is going to stay there, but in place of sine squared plus cosine squared, I'm going to use its identity and do the substitution, and its value is 1. Now be careful that you don't stop short when you're working through this problem. I now have 1 over sine squared, which yes is simpler. But when I see sine squared in the denominator and a 1 in the numerator, that makes me think of the reciprocal identity. So when I get to this point, I'm thinking, oh, this looks like the reciprocal identity. And so if I go and look at my formula sheet, which I'm going to do, okay, and I think about a reciprocal identity, it shows that cosecant is 1 over the sine of x. Well, I have sine squared, so I could use the same relationship that cosecant squared is 1 over sine squared. So I'm going to use the reciprocal identity that cosecant squared x is 1 over sine squared x. So again, it's really a direct substitution. By definition, 1 over sine squared x becomes cosecant squared x, which would be your final answer. That it is in simplified form at that point. Okay, a couple more. Simplify 1 plus cosine squared times 1 plus cotangent squared. Now, I've got a binomial or 2 pieces times 2 pieces. You may think, well, I wonder if I could FOIL that out. Well, we could, but we could also try to simplify it. If I think about 1 plus cosine squared, I might again think about those Pythagorean identities. We know that 1 plus cotangent squared is cosecant squared. So that's kind of what was probably triggering in my brain. That is that this second piece here reminds me, this 1 plus cotangent squared reminds me of Pythagorean identity. Now, again, you may not be as familiar with these as I am, and things may not jump out at you. Okay, but typically when you see something squared, your first place you probably want to start is with one of your Pythagorean identities. Okay, and it is 1 plus cotangent squared x equals cosecant squared x. So again, I'm going to write the problem down, but then I'm going to do that substitution. I have 1 plus cosine squared x times 1 plus cotangent squared x. Now, this first piece, 1 plus cosine squared x, is going to stay, okay? And instead of 1 plus cotangent x, I'm going to use the Pythagorean identity, and this becomes cosecant squared x. Now, the other piece there still does make me think of a Pythagorean identity, although it's not as obvious because we have sine squared x plus cosine squared x equals 1. So I'm wondering, could I solve this particular expression for cosine squared? I think I could. So if I do that, I would subtract sine squared from either side, and I would have cosine squared x equals 1 minus sine squared x. So sometimes you have to do kind of an algebraic manipulation to the problem or to the identity for it to work. So here I would have 1 plus, and in place of the cosine, we're going to put 1 minus sine squared x, okay, times, and we've already done the substitution for cosecant x, and it'll be a little bit more obvious in a minute why we changed everything to sine, okay. So then if I do that simplification there, we have 1 plus 1, which is 2, minus sine squared x times cosecant squared x. Okay. We could distribute at that point. We have 2 cosecant squared x minus sine squared x cosecant squared x. But then I remember from just a few minutes ago that cosecant is the reciprocal of sine. So then I'm going to have 2 times the cosecant squared x minus sine squared x, and I'm going to use the reciprocal identity, okay, and that would make this 1 over sine squared x, which gives me 2 cosecant squared x minus sine squared x over sine squared x when you multiply it together, which hopefully you realize is going to be a value of 1. So ultimately, when I'm done, okay, I have 2 cosecant squared x minus 1 whole. And you may think, well, Miss Ralston, that's not a whole lot simpler. Well, it's a little bit simpler, okay? And so it's better than it was. I no longer have a multiplication problem. I just have a flat, straight out equation. All right, let me see if I can I've got 2 more examples here I'm going to try to work through for you. Again, the first one here, I have secant squared x minus 1 over sine x. And again, in the numerator here, I notice, oh, wow, I've got a squared term. And again, so that makes me think of a Pythagorean identity. So again, it may not be as obvious, okay, but we're going to see what we can do, okay. All right, so again, that makes me think of the Pythagorean identity. And we can go out and look at it, okay, just to make sure we get it right. 1 plus tangent squared equals secant squared, okay. So 1 plus tangent squared x equals secant squared x. And you may think, well, Miss Ralston, that's not what you have there. But there again, if we do a little bit of algebraic manipulation, if I subtract 1 from either side of this expression, I get tangent squared x equals secant squared x minus 1. One thing that may help you is on your formula sheet is to go ahead and solve your Pythagorean identity for all the different values. I'm going to solve it for tangent squared x, which is secant squared x minus 1. You could also solve it so that you have it equal to exactly 1, which would be secant squared x minus tangent squared x. So it may help you to write it that way. So again, now that I recognize that, I can rewrite my problem. So I have secant squared x minus 1 over the sine of x. Again, I'm going to do a substitution. Okay, I'm going to replace secant squared x minus 1 with tangent squared x. Now you may think that doesn't help you very much. Again, I have tangent squared, but tangent is also a reciprocal identity. So I'm thinking that I can use the tangent and cotangent identities. And we have those. Look. We have tangent and cotangent identities. That tangent is sine over cosine. So I'm going to use that relationship there and do a substitution again. Sorry. Okay, so I would then have the denominator is still going to be sine. In the numerator, I'm going to use that tangent and cotangent identity, and I'm going to replace that with sine squared x over cosine squared x. Now remember, mathematically, that big fraction there is actually a division symbol. So this is like having sine squared x over cosine squared x divided by sine x. And if you remember, divide fractions, we flip and multiply. Okay, so you see that. So I have sine squared x over cosine squared x times 1 over sine x. And so then if you go ahead and multiply those out, you may want to, okay, you're going to have sine squared x over cosine squared x times sine x. And then I realize that I have one sine in the denominator and I have the numerator, so I can divide one of those out. So it doesn't turn out great, but I have sine x over cosine squared x. And that's probably the best I'm going to be able to do for that problem. You know, it's simpler. Again, you have a single term in the numerator, single term in the denominator. Okay, one more. Again, I've got cosecant squared x and divided by cosecant squared x minus 1. This time, I'm looking at my denominator, and it does make me think of a Pythagorean identity, so I'm going to go out and look. My Pythagorean identity is 1 plus cotangent squared equals cosecant squared. Okay, so let's see what happens if I use that Pythagorean identity. Okay, so I have 1 plus cotangent squared x equals cosecant squared x. Here again, you may very well want to solve this because it doesn't look like what you have. Again, if I subtract 1 from either side, I have cotangent squared x equals cosecant squared x minus 1. So that's going to allow me then to make a substitution. So I have cosecant squared x over cotangent squared. Whoops, I was going to write down the problem again. Sorry. Let me fix that. Over cosecant squared x minus 1. And then I can do the substitution. I still have cosecant squared x in the numerator, and I'm going to substitute cotangent squared x in the denominator using the Pythagorean identity. Now at least I have a single term in the numerator and a single term in the denominator. I think now I may use the reciprocal identities and my cotangent identity to convert everything to sine and cosine. Sometimes that's the best way to go. So cosecant is 1 over sine squared x. Cotangent is cosine squared x over sine squared x. Again, remember that's like a division problem. You'd have 1 over sine squared x divided by cosine squared x over sine x. So we're going to flip and multiply. When I flip and multiply, I have 1 over sine squared x times sine squared x over cosine squared x. And if I write that out, I'm going to have sine squared x all over sine squared x times cosine squared x. And then I notice that I have sine squared in the numerator. I need a placeholder of 1. Sine squared in the denominator. So I have 1 over cosine squared x. And then I remember, oh, that's a reciprocal. 1 over cosine is, I believe, secant squared x. Guys, a lot of it, you're just doing really old-fashioned algebraic manipulations. You're doing substitutions and then simplifying. Substitute and simplify. A lot of it's going to be getting familiar with those identities, or you need to have those where you can easily access them as you're working through these type problems.